Howdy, everybody. Hope you're doing well, whenever you are. We're here for Everybody Codes, quest number 5. This is the last week, or the last day of the week, I think. Please excuse my voice. I got a bit of a cold. It sounds like I'm sucking on something. It's just I got a cough drop in there to try and help out. Lots of good stuff from yesterday. I think that's the thing. You'll always be improving, learning new things. So thank you all for your input and some of the stuff that you sent. Let's just get on with the day. Okay, story section for part 1. You arrive at the garrison shortly after sunset. Upon arrival, you discover towering stone walls encircling a spacious courtyard, illuminated by the torches strategically placed around where knights, despite the late hour, are engaged in sword fighting. Around the square, hundreds, if not thousands, of tents have been set up. The captain assigns you one of them so you can rest after the journey. The next day, as you stroll through the square, the captain approaches you to exchange a few words. "Hello, friend," Sir Mandelbrot told me. "What brings you to us? In a few days, we'll be escorting a herd of nerd masters to the Stack Trace Sanctuary. You can join this expedition if you want." "That's excellent news. Thank you very much. Might there be a way for me to express my gratitude?" "I've heard that you have an extraordinary talent for solving problems. We have a few matters to attend to here that require a sharp mind, but don't take this as any expectation of you. If you want to learn more details, go to the armorer. You will find him in the middle of the square, by the large chest. We received a delivery of new swords for the garrison early this morning." Excited, you almost run to the square, unable to wait for the next puzzle to solve. You feel that with each solved puzzle, you grow stronger, and it brings you immense satisfaction. Okay. You find the armorer copying the numbers on the sword's hilt into a book. Noticing your interest, he explains to you the meaning of the numbers. Each sword is marked with a unique identifier, followed by numbers that allow to determine its quality. The numbers are separated by commas, but it's a simplified representation of a structure called Fishbone. To determine the sword's quality, you need to build a fishbone from the given list. Combine the digits written on the spine into a single number, starting from the highest segment. An example fishbone looks like 357 1810 5978. The central part connected vertically by pipe characters is the spine. So this one. Yeah, in the example above, the spine consists of 4 segments, 5897. So its quality is simply 5897. Each segment can have 1 or none on the left side, which must be less than the value recorded in the connected spine segment, and 1 or none number on the right side, which must be greater than the value recorded on the connected spine segment. These numbers determine certain special characteristics of the sword that are only significant for very skilled knights. Okay. So 5 is greater than 3, 7 greater than 5. To construct a fishbone from the listed numbers, the first element from the list should be placed as the first segment on the spine. Are we doing some kind of binary tree? Although this is not binary, I guess. So I don't. There must be some fishbone in computer science. I'm not aware of. The first element from the list should be placed in the first segment of the spine. Next, we add the subsequent numbers one by one according to the following rules. Check all segments of the spine, starting from the top. If your number is less than the one on the spine segment, and the left side of the segment tree is free, place it on the left. If your number is greater than the one on the spine segment and the right is free, place it on the right. If no suitable place is found in any segment, create a new spine segment from your number and place it as the last one. So this one could have gone something like 5, 7, 8, 3, 1, 10. This 10 would have had to come before the 9 because the 10 plops here, and now there's nowhere for the 9 to go, so it goes down. I think that's what it's saying. I actually don't. I've never seen this data structure before, so it'd be interesting to know from you, like, have you seen this data structure before, and like, why wasn't it in my algorithms class or whatever? You're looking at the numbers being recorded by the armorer to see if you can construct a fishbone from them and determine the quality of the associated sword. First number is the identifier, and then you have this set of wishbones, or these values. So you start with 5, 3 goes to the left, 7 to the right, 8 down, 9, 10, 4. 5, 7, because it's less, so 7 goes down. Now we have an 8, which should go left, but it's taken, so we go down here. Now we go greater. And then another 8 would go here, but can't, so it goes down. The quality of the sword in this example is 5, 8, 1, 1, 0, 7, 8, because this is a 10. Gotcha. I'm kind of curious. I think the data structure I would use is just like a vector of segments that has a left, middle, right. Fishbone diagram. This doesn't look like the same. Okay, I mean, I honestly don't know what it is, so this may be a fun day because we'll learn. It may be a boring day for you because I have no idea what I'm doing. Usually, you know, if it's like, oh, graph traversal, I know some kind of algorithm. I've never used this fishbone before. Hopefully it's not too hard though. EC watch 5. So we know we're going to get a number. Where's my thing? It's going to look like this. So let's return a vec of U size. U size, they all look like they're non-negative values. I guess I didn't look too close. They are not. It doesn't look like I size or U size matches though. So we'll do let lines equal this. Because I want to get the first. So we'll say let ID equals lines 0.parse U size dot unwrap. And then we'll say let, I guess we can just return these now. So we can do Oh, it's per line. Interesting. I only get a single line. Will I get more than it is actually like this is what. I guess I actually want to do this. Split once on this. Dot map LR. So we want to turn L dot parse U size dot unwrap. This was dumb. I was thinking about like caddis and other problem solving things like that. And so now let's do R dot split comma dot map and dot parse U size dot unwrap. Dot collect. Very surprised if that works. First time every time. Okay, so let's create this fishbone. Type, okay. No, fishbone. Oh, is it a wishbone? It's got like 3 things. And then we want to have some options on this. So we'll say like impl fishbone. If and new, we'll create like a blank one. Like an empty one. Should we just for testing derive debug? And let's do fn try place self. So this is where we want to perform the logic. Should I make these options? Oh, I could probably impl default here too. I don't have to do new. So what does this try place do? We say if middle dot is self dot middle dot is none. I guess we need a U size. So value U size. Self dot middle equals some value. Return. Else if we could probably do these in matches. Let's try that. self.middle. This is actually the none case. Like if there is no middle, we return that. If there is a middle, we want to match on v.comp value. Value.comp v is actually what we want to do. And if it's less than, we want to match on, this should return an option. So if it's less than, we want to match on self.left. And if it's some value, then we know we can't place it. So we return none. Got it. Okay. Greater. We're going to check it on right. Oh, let's see. None here. We want to place. We want to say self.left equals some value. And here we want to do the right. If it's equal, we want to return none. Oh, in these places, I don't want to do this. I mean, I guess what I want to do is like, we do this and we do some. Like that. What doesn't like about this? Do I need to dereference or reference it? Okay, is that the right logic? Check all segments of the spine starting from the top. If your number is less than and the left side is free, place it. If it's greater than on the right side and it's free, place it. Otherwise, put it below. Okay, so I do like, I'm not going to use the ID for the first part. So we'll create our fish bones. And we'll say for value in values. What is this going to be? We're going to return a string. And in the end, it's going to be fishbones.iter.map. The middle dot to string dot collect string. I guess I can create one fishbone default. We got to start with one, right? Let's impl display for this so we can call it a string is what I'm thinking. So if there's some v, we write f v, otherwise we'll write f none. Oh, I kind of want to have like a, well, we can do the logic in here. So we'll say like for fish bone in fish bones iter mute. We'll say if fishbone dot try place value dot is none. No, is some. So we're going to say like, oh, I'm going to try and place this value. And if I ever find one, I'm going to put it in the middle. If I don't, if I ever get to here, I know I wasn't able to place it. So I'm going to do fish bones dot push fish bone dot default. This looks kind of ugly, but so we'll refine it after. We'll say last dot try place value, and then we'll do fishbones dot push last. Okay, I mean that seems like a lot. I would like to try it with the other input though, just so we can test this. So let's get this one. That didn't work. Five 81078. Okay, that does look like it worked. So we can clean up the logic in a little bit in a second. Let's see if that. Okay. That did take us a little bit of time, 26 minutes. Do we want to, I guess this whole thing is a fishbone. So I kind of want to do like node. Maybe, yeah, node is fine. And then we like do this for a thing, derive debug default struct fishbone, and it's going to have nodes of vec node. We'll impl display for it. We'll do self.nodes.for each. We can do map. Oh, okay. You learn a new thing every day. Okay, so we don't actually use this fishbone, but we can do a simple fishbone fn insert mute self value usize. And then we can actually put the logic in here. The logic still feels really ugly. I think we can do all this logic in here. So for Fishbone and Fishbone.itermute, try place. Return. Otherwise, we do this. I don't know what happened there. Then we can do values.iter dot for each. Will into work here? We have to do toString. Or 864, is that the same one we had? 486486573 Okay. This is still a little ugly. How would we do this? Like, we basically just want to, we do want to do the try place, but maybe we just have it return a bool. So we can impl new, then maybe would be nice. Fn new value usize. And we do self left 0 or none middle some value right none. And so up here we just do self nodes push node new value. Now let's update the try place. True, false, true, false, true. I mean, that looks a little bit better. Okay, that's good enough for me for part 1. Let's move on to part 2. Uh-oh, it's changed in part 2. We're going to get multiples, I can see. So before I even read the problem, I'm going to change this to... nope, not this one. This one. So we're going to get a vec of these. Oh, should I just actually... I kind of want to return a vec of Fishbone. And we can give it an ID. So, fn new ID usize Fishbone ID nodes vec new. Like that. Oops. Then up here, we want to input trim. I actually don't want to put this here. Oh, I can. I do it like this. And I do... This is actually, I don't like doing it this way. I changed my mind. So let's do usize. Vec usize. Like this. So we're going to trim input lines. And then we're going to dot map L. We're going to do this and return that. Like that. First time every time. So this one is actually going to be values. And so we're going to do values 0 because there's only one. Oh, okay. You provide the correct quality value immediately after the armor finishes writing down the last digit on the list, which leaves him stunned. You explain that you came to help him with his work on the captain's orders. The armorer is delighted and states that with your skills, the task will definitely go much faster. You receive a list of swords designated for the best squires as a reward for your service, for their service. The armor must check how much their qualities differ by finding the best and weakest sword and calculating the difference between them. You glance at the list to see how the numbers are written and arrange themselves into fishbones, which begin to glow with a faint light visible only to you. The quality of the swords assigned are these values. In this example, the weakest is this one and the best one is this one, and the difference is this. Okay. So we're going to do our input, and we're going to do like let fishbones equal input.iter map. Still don't need the ID. P or no, like VV, I guess. And we're gonna do basically what we did up there. So we're gonna do. Oh, I guess we can get. I guess we do have it. Make it more readable. So we'll say. Let fishbone equal. I can just copy this. Can I blame all this bad typing on my thing, or do I always type bad? Do this. Oh, so should I just do this? Oh, I still have to do it right here because it's a pointer. So now we collect them and we do fishbones.sort. And then we return fishbones fishbones.len -1 minus fishbones 0. Close. Cannot move a shared reference. So I will have to do this. Still haven't used the ID. What are the odds this is correct? 100%. Never didn't have it, right? Okay, so what's the thing here? Part 1 was like, can I just create this fishbone data structure? Which I still like to think about a little bit more. I don't think this is too bad. But then part 2 was like, okay, now can you create a bunch of fish bones and then do a comparison of the two? And so that wasn't hard. So we basically just iterate over all of them, create a fishbone. I almost want to do a fishbone new, you know, give me an ID and give me the things. And I do like the try insert. And that would like simplify this. So, for example, if we change this new to values VV or like U size, we can call, so we can say let mute nodes equal I kind of want to make the fishbone and then we do like that. So now up here, I actually can, well, I can still return this. But what we can do then for P1 is we can just say Fishbone new input 0. Oh, I should make it a like this. Like that, I think. So because then I can do Fishbone dot to string. Like that. Found usize. How do I, because what it means is I have to do like input 0.0 and then ref to input 0.1, like is what that one's saying, which is kind of ugly, right? It's a pointer to back usize. Okay, I mean, it's kind of ugly. But what it means we can do here is we can just do Fishbone new. I'm going to have to do the same thing here. So I just will do this. Oh, this is already a pointer. Okay, is that the same? 88412404781. Okay. This one looks okay because you're destructuring it. I guess we could do like maybe that makes it look cleaner. I don't know. I'm spending a lot of time like mucking with it as opposed to just solving the problems. I think I do that a lot when I have like a new algorithm. Okay, part 3. Hold on one second. I gotta go get someone. Sorry. Okay. Wait a minute. How long have I been on mute? Bugger. Hopefully I muted myself just as I went out. I had someone at the door. Okay. Part 3. Without delay, you provide the result and point out the best and weakest sword to the armorer so he can verify it himself. It looks like you are correct. So the knight hands you another, slightly longer list of swords. This is a list of all the swords intended for knights. The swords should be sorted from best to weakest, but unfortunately they got mixed up during transport. However, a checksum of the sorted swords is included in the package. So after restoring the correct order, it will be possible to verify if nothing got lost. The rules for determining which of the two swords is better is as follows. If two swords have different qualities, higher quality is better. If the quality of both are the same, the numbers resulting from the subset levels of the fishbone should be compared starting from the top. A higher score on the first level, which differs by swords, indicates a better sword. If they're not met, they have identical swords, the sword with the higher ID is considered better. So we have these two swords. And then it said, yeah, so there's a 4-9 here and a 5-9 here. So this 5-9 is better. So we're going to get a list of swords. We sort them. And then to calculate the checksum, we need to multiply the identifiers, so the IDs, by their position on the sorted list. So I think we need to implement sorting on these things to get them. Let's try it. So it probably is a good idea that we implemented a fishbone. So now we can impl. Actually, I always forget. Is it partial equal or equal? Rust how to impl compare. Here's what it's telling me. Sorry. Partial equal. And partial ORed. So those are the things we need to impl. Is that right? So if we impl partial equal for fishbone, what makes them equal? They're only equal if they're I wanna FN quality. Self U size. Since we're doing comparisons of this. I mean, it is cheating, but we basically just do self.to string.parse U size. Right? Dot unwrap. No error checking where we're at. So if we do FN equal, and we just say self dot quality equal other dot quality. So, and then we want impl partial ord. For Fishbone. Okay. So we say if self dot, or maybe we should do a match on self dot quality dot comp other dot quality. And so if that returns less, then we should return, that means self is less than comp, so we should return some standard comp ordering less, right? If it's greater, then we should return greater. If it's equal, then we need to do our funky logic. So we can do like how does zip work? We could try it with a zip. So we could do for LR in. We know their middles are equal at this point, so we're only checking their lefts and then their rights. In what order did they tell us to do it in? Da-da. So we go left to right. So we only need, we want to compare the lefts and the rights. Lefts, right, lefts, right. I don't remember how this zip works. So this is not quite what I want to do. I wonder if there's like another, is it no, not intersperse. Let's see. Rust zip 2 iters, but none. Option on both sides. Something like that, right? The most idiomatic way to do this is zip longest with iter tools. Is this the fastest way to do it? Okay, let's try it with iter tools. Zip longest. So we can match on E, and it can be either or both. LR. So if they're both here, we want to say L dot left dot comp L dot right, then L dot no R dot left, then L dot right. Dot comp R dot right. I'm probably making this harder than I need to. We return at this point because we found like a displacement. And then we say either or both left. In this case, we know self had a value on the left. So we return some standard comp ordering greater So we go through the whole list. If they always are equal, no. Okay. This is not quite right. It should be like match on this. We're going to match on comparing the left and the right side. And we'll say, we'll do the same things. So if it's less, we return less. If it's greater, we return greater. If it's equal, I probably complicated this too much, huh? We want to continue. So that gets us in the for loop. And then if we're ever at this point, oops. Okay, so in here, we'll return L.id, no, self.id.comp, other.id. I gotta add these to all the things. Ugh, what are the odds that this works? Okay, so we're given 2 fish bones. The question is like which one is of lower value. So we just do a comp on the quality, and if it's ever less, then we return less. If it's ever greater, we return greater. If it's ever, if otherwise they're the same, so now we have to go down the list. So we're gonna do zip longest. So we go down the list of them. If we only have a left or a right, meaning like this one has gone further, actually that should never actually be the case, because their middles are the same, but we'll leave them in there. We return if it's the one on the left, meaning it's self, we return greater. If it's the one on the right, we return less. These two will never happen though. Otherwise, there's going to be both there. And so now what we have to do is we want to compare the left with the left's left, or self left with other left, then self right with other right. If it's less, then we return less. If it's greater, we return greater. Otherwise, they're both equal. So now we continue, we keep looking in our for loop, right? And eventually, if we ever find any of those, we finish. If we never find it, then the only thing left is to compare by IDs. Okay, so I want to try that on this one. So for P3, we're going to do let input equal parse input part 3. Remind me, I actually didn't. Well, no need to remind me because I did it immediately. So part 3, what are we going to do? We're going to do this. And then we're going to do fish bones dot iter dot enumerate dot map if. And what are we doing? Identifiers by their position on the list. So we do f dot id times I plus 1. Why doesn't it know what ID is? What does it think this type is? Usize. Huh? Oh. I need to impl ord. Okay. So we'll impl ord for Fishbone. Self dot PartialCmp third dot unwrap. How do you impl equal? Rust impl equal. Boy, I'm learning a lot about this. Standard comp equal. Oh, do I just put equal up here? Nope. Oh, I need to impl equal here. Nope. In node. No implementation for node equals node. Well, that's not right. So let's print them out. Fishbones.iter.enumerate. For each if will print out print line I plus 1 f.id. Eight 7 9 4 2 1 6 5. I got them in the wrong order. Oh, highest to lowest. Wait, what is this saying? Non-canonical? Yeah. Yep. Is it because I should just impl ord? I'll figure that in a second. So I just do rev, I think, right here. Nope. Here. Okay. That is a little surprising that I got that first time. Ish. No. I had this one right, didn't I? No? Oh, what just happened there? 14. Oh, something's wrong with this. One, two, three, four, five, six, seven, eight, nine. What doesn't it like about this? I literally just did this. Three, five. Huh? Oh, I'm not doing the rev here. Three, five, six, one, two, 4, 9, 7, 8. 260. So the actual input, and we do have a lot of them. I am using U sizes. Always check that, right? U size, FID times I plus 1. FID I plus 1. Okay. So it must be in my sort. The higher identifier is considered better, so check. So the checksum is this. Okay, so should we try this one? One, 2 plus 2, 1. So this one seems to work as well. Okay, let's look at the sword again. What wiggity whacked. Okay, should we try and fix this? Non-canonical implementation. Oh, I should just I should impl partial board here, and then I should now we get rid of all these. Paratel. Oh, is this silly? Am I overanalyzing this? I feel like I'm going in circles with this silly little thing. In Rust, should I impl ord or partial ord? Okay, why don't I just impl ord? If you derive partial ord, you cannot impl ord. Can't compare Fishbone with Fishbone. Sorry, I'm just trying to figure out which one I should do. This is a little annoying. Isn't this just what I did? If partial ord and ord are implemented, they must agree. This is commonly done by wrapping the result of comp in sum or partial comp. Okay, so it is, I need to do both. You do comp. Like this. And then we impl partial ord for Fishbone. Fn partial comp sum self comp other. Like, is that what it's saying you do? Oh, I have it right here still. Okay, you're no longer mad at me. Okay, so like that's helpful to know. I I think I've gotten these mixed up before. If you're doing your own ordering, the answer is impl ord, and then if you impl partial ord, you just wrap it with some self comp other. Okay. And this is like, they have both ord and partial ord. Ord is like usually doable, right? But think about like a floating point number. I think that's the issue. And so that's why they have partial ords. Like you can't compare two not a numbers or something like that. I don't remember exactly what it is. It's something along those lines. Okay, but my thing is still wrong, presumably. But now I don't have the giant thing looking at me. Is it just like... Ooh. Zoom. Now I have a bunch of stuff. Clippy lens. This is the one I want. That doesn't actually change it. 30900 Best to weakest and provide their checksums. To calculate the checksum you need, multiply the sort ID by their position on the sorted list, starting from 1. I guess this I can do sort by like that, and then I don't have to do the rev. Oh, I do it like this. What else should I print here to help me understand what's wrong? Okay, so there's ones that are definitely equal to each other. Is it like this where you go... like that, so it's formatted? So let's do Fishbones Windows 2 map or dot for each. I want to check and see. So if w0 dot quality equals w1 dot quality, we'll do like a print line, or let's see, for V and W0. Maybe what I should do is let's do the match again. Trying to think how I want to print these. So maybe I print L, print R, and then print line and have a empty one. We just print line L. And the print line R. Okay, so that's the same. Oh, let's I can just do this, right? That's what it doesn't like. 39 none, 247, 69 none, 69 none, 259, 259, 259. You know what I gotta do here is like nope, I want to do it right here instead. So these ones are actually equal, literally equal, it appears. No, right here. They aren't. Should I impl? It might look better if I impl print line for node. Or, yeah. Sorry, this one's taking a long time because I feel like I'm. So we oh, we can't do that actually because we've done this right here. Can we impl debug? How does that work? That's funny. Well, I guess I gotta do this. Okay, that does make it easier to see. And so, yeah, this one differs right here. One is less than 3. Is it this equal? No two swords are equal. Does that change anything? I mean, it is a little weird. Compare their qualities. Higher quality is better. Okay, so less to less, greater to greater. If they're equal, oh, we turn them into a number. This is where I'm wrong. So I can do this equal thing easier. So we can say let ll equals self.nodes.iter dot map I want to just like smash the values together, it sounds like. So it's going to be It's getting really, this doesn't feel like good code, but we'll do this. And middle dot unwrap or I don't need any of this then. And then we just do ll.comp rr then what doesn't it like about these? This is getting ugly, but I'm getting tired. And I'm sick. Is it like that? How about that? Does that change my answer? It actually does. Still not right. Oh, 1.2.parse usize unwrap. What do you think? What are the odds it's that? Okay, it feels very ugly, so let's start thinking about how we clean it up while we wait for 4 seconds. Okay, we got there. So what was that? Impl sort. And apparently the answer was I cubed can't sort. Or it takes a long time to figure out how to do the sorts. It is a thing I struggle with in Rust, is impling those traits. And it's something that I probably need to work, especially this one was somewhat complex. And it's clear that I'm not doing, I'm just like fiddling about, but I actually don't mind doing that a little bit because I'm more of a get it done and then refine it type of guy. Although I'm sure you've seen me before do a lot of refinement. So let's see where this goes. A fishbone has a quality. And it's like smash the numbers together, unwrap it. Do I want to change this? Because that was a little annoying in my iterating. We'll probably just get rid of this now, and we can just, I mean, we don't need it, period. Okay. Do we use default either? I don't think so. But I have seen in comments before that people just like have like 7 things that they derive by default always. And I think in the end, your code, like the machine code, doesn't change anything because it will prune out the stuff that you don't use, right? So maybe it doesn't matter. So how do we when we're doing this display, there's another way to do this with integers, but I'm kind of inclined to like remove this and then just always return the quality, but we do like self dot nodes dot iter dot map. There's always going to be a middle, right? There's no reason to not have a middle. I mean, I guess we leave it in here. The options I'm not feeling very good about. Anyway, let's try this end dot middle. And if it's sum v, we return v dot to string. Otherwise, for none, we return like that. Are those the same answer? Looks like it. Okay, I want to keep refining like a little bit, and then we'll check stuff. Sorry, I know this one's already been long. Does this look easier if it's like, let's try it this way. If self dot middle would be this. I don't think this is any better. I mean, this one looks okay. Maybe. What would be another way to do this? What's like another way to do this? Just so I can say like, does that better? The if one doesn't really work because you're basically turning each of these into an if else, and so you arguably have 1, 2, 3, 4. Could you do like if let some self dot middle, no, let some v equal self dot middle else that and then we do this in here. Does that look better? I guess we don't need this else here. Does that look better than that? This feels more idiomatic Rust right here. Of course, I know a lot of people like if let some. Could you use if lets in here? I'm going to leave it the way I have it, I think. But tell me how you did it. Maybe you have another way to do it that's easier. the gist of what you want to do is be able to like put a value in. Oh, do you know what? Because I don't use the news, the middle actually is always a value. Does that work? Nope. Oh, I can just do this. See, I actually want to impl this, I think. I actually kind of, what I actually think I want is a function that's like the value. So if I do like this and I do that. We can also just have a values function. So if we do So we just do self.values.comp other.values. Like that. Now it's starting to look a little cleaner. Oops. To string applied to a type must display in format args. Remove this to string. Oh, it's an actual value, so I don't have to string it. Let me just call this place. Actually, I like try place. That's fine. So now I have these helper functions. Create a new node with value in the middle. Return the value of the node for P3. Is that what they call it? Okay, we'll call it number, because that's what they call it in the problem. What happens if I put left in here? Probably doesn't because it's an option. It'd be interesting to know what a good way to do this is. Again, this one like the issue is like it could be more than one digit, and there's a way to determine how many digits you've used. I think I've done it before in a problem, but I'm feeling tired and we've gone a long ways in this one, so maybe we call it quits here. So we reverse sort. Calculate checksum. Get all the fishbones. Do you remember what it used to look like? This function? It was ugly. I think it looks a lot better. So why was I not just willing to do those things? I probably should have thought through this equals a little bit more. And that would have helped. Okay. We've done a lot of code stuff. Conclusion. I've done a lot of my conclusion is like really weird. I think the day overall was good. I made a lot of changes to the code to make it a little bit cleaner. So skip back a little earlier if you want to see me do the code cleanup. I don't know why you would. But I think overall it's looking a lot better than it was to start with. Feels much more idiomatic. Maybe I can add some comments here. Okay. Wait, this one's called numbers 2, right? Get the... Okay, that feels... At least I've added some comments, so it's somewhat understandable. Okay. So I think I'll submit that. Let's just see. So I did spend a lot of time iterating over this one. An hour and 50 minutes total. Yeah, I guess we're going into the 2-hour mark. I mean, I'm still doing okay, I guess. I'm sure that the global the guys on the leaderboard did it pretty quick. So part 4, 2 minutes. Wait, is that guy's not AI? I mean, I guess if you know what a fishbone is, again, I don't know what a fishbone is. So if you've seen one before, tell me what it is. It's a new data structure from my perspective. I'd be interested to know. Oh, I need to see my duck. What's happening now? More stars? How many more stars can we get here? 1, 2 more, and then something else has got to happen. So 2 more days. Okay, let's look at a couple solutions for a few minutes. See if we can't do some refining of our own. Vanilla iComparable T implementation. Yeah, is that what people did? They implemented comparables. Heck. Is that suggesting you can just compare the vectors left to right? I thought that's what I was doing. Man, did I over-engineer that? Can I just do self.nodes.comp other.nodes? What doesn't it like? Oh, Vec doesn't impl comp? Why is that not the case? I would definitely think you'd be able to do that. Make comp key. I'm really liking nom v8. Oh, let's see how they did their nom parsing. Were all the numbers small enough? Did I miss that in the input? Oh, bother. They are. Okay, so I totally missed that in the input. Like, what does that mean? Is like, the quality is just get the middle one. Oops. Dot fold. 0. Okay. Okay. I originally used a cat or string and then parsed. You could also do the log trick to find the number of digits to multiply. I've done that before, I just don't remember how it works. So okay, yeah, that's you definitely want to do that. Left and right. If n less than spine and left is none, this looks a little bit more concise. So maybe this is a better way to do it. Oh, it's called a segment. I should change that too. They do call it a segment in there. I do like calling it segment. Okay, so this is the parser they use. Yeah, separated list 1 by comma, and then a U64, map it to self. So like this is a, like if I were doing error handling, I would totally use this type of thing. You can see in my parser, it's just like a bunch of unwraps. I use 3 unwraps, and we've talked about that before in videos, right? Like the question is like which unwrap do you use, or when do you use unwrap and not? And you know, in puzzles, I'm inclined to say you don't need to use or you can use unwrap unless you're interested in practicing error handling, because error handling is a special thing. Understanding like results and stuff like that are important. Obviously, if you're using production code, like I'm writing some libraries at work in Rust, and 100% no unwraps, right? You don't want any form of panicking. So make comp key quality level ID. Interesting. You can sort by this right here instead of like straight up impling. Okay. That's true. If you just return 3 values, we can do that. Okay. I think the problem I had is I misread how the middle works, or how it works if the qualities are the same. Like my thinking was compare the 2 left numbers, then compare the 2 right numbers. But really what it was saying is smash it together. So that's on me for not having read the stuff. Good reminder to read the stuff. Okay. Otherwise, pretty much the same. libc q sort. Should we look at some C? Okay. We just assume no spine is going to be more than 128. So initialize them to -1. This is a common C trick, is to say, especially in programming like this, is I know I have some upper bound, and so I know I can use that to my advantage. It wouldn't be too hard in C to impl a linked list, where you just add on to the end, because you are going to be iterating. Although this way is fine too. I was always a big linked list fan because I came from Lisp. Clunky, but if it works, it works. It's probably not as clunky as my initial one was. Okay, this is similar to what I had before. The one thing I was missing is that, like, comparing the two levels, you could just compare them one at a time. This is another way to do it, is you go through them until you find it, and if it's been handled, you do something different. Like if it hasn't been handled, then you can add one to the end, right? Yeah, right here. So you keep track of like a temporary variable. Let's see, what else do we got here? JavaScript. Checked that one. I'm always interested in looking at the Rust ones, but it looks like this is all we've got. So instead of staying at home and programming a puzzle, people are out having fun. I'm just kidding. I'm going to go out and have some fun too. Anyway, that one was a lot of fun. Hopefully, sometimes it feels like, can I blame it on my illness? But sometimes it feels like, you're trying to do something in Rust that's, oh, I should impl PartialCmp or partial equal or whatever. And then you end up spending 2.5 hours solving a problem that's only, in total, 200 lines of code. That seems crazy to me, but, and especially when, like, some of these things turned out to be like substantially simpler than I made it out to be. So that's another, I just need to be better at reading the problem thing. That's on me. So, okay, well, I think we're going to call it here. This was fun-ish, mostly because I'm sick, but it was fun to solve it and to work on learning some of these things. Now I know you impl ord, partial ord, you just do some of that impl. I think I've done that before. So there you go. Thanks, everybody. We'll talk to you next time. Bye.